Hello students, welcome to JCE Connect series of lectures. So in previous class we have discussed about notches, various types of notches, the derivation of notches, then the velocity approach, then Francis formula, then Shaped Weir we have discussed. In this particular session we will be discussing about weirs. In that also there are various types of weirs: broad crested weir, ogee type of weir, narrow crested weir, and sharp crested weir. There are so many types of weirs. As you all know, a weir is basically an obstruction in the flow of path in an open channel. The weir will cause an increase in the water depth as the water flows over the weir, and in general, the greater the flow rate, the greater will be the increase in the depth of flow, and the height of water above the top of the weir is the measurement usually used to correlate with the flow rate. So we all know the definition of weir and the function of weir also, and the picture what I am showing here is depicts the weir picture. Just it's an obstruction across the flow, and it is running along the width of the channel or river. The top portion of the weir is called as a crest, and the water flowing over the crest, it is in the form of a sheet, and that is called as a nappe. That you all know that one. Okay. And the types of weirs, if we want to discuss, there are different types of weirs based on the shape and based on the nappe dimensions. The weirs are classified as various types. So weir with sharp upstream corner or a edge such that the water springs clear of the crest is a sharp crested weir. Sharp crested weirs are classified according to the shape of the weir opening, such as rectangular weirs, triangular weir, or V-notch weir, trapezoidal weir, and parabolic weirs. And weirs are not sharp crested are classified according to the shape of the weir, shape of their cross section, such as broad crested weir, triangular weir, and trapezoidal weirs. And as we know, weir it is generally in the form of a vertical wall with a sharp edge at the top running all the way across the open channel. This is the generalized definition of weir. And if you look at the classification of weirs according to the shape of opening: rectangular weir, triangular weir, and trapezoidal weir. And the trapezoidal weir, a special type of weir, it's also called as a Shaped weir. And one more type of classification if we want to make for a weirs, it is according to the shape of the crest. As we know, the crest is nothing but the top portion of the weir is called as a crest. And based on this crest, if you want to classify weirs, that is a sharp crested weir, broad crested weir, narrow crested weir, and ogee shaped weir. So Sharp crested weir, as the name itself indicates, the crest is sharp. And broad crested weir, the crest is broader or wider, and the narrow, it is in between, that is sharp and broad. It's a narrow crested weir. And ogee, it's a particular shape, that is a reverse S curve, we can say. But how can we understand whether the crest is sharp or a broad or the narrow? It is based on the B by H ratio. The B by H ratio. B means width of the weir. This one, this is the width, or this is, you can take as a B, is the width of the weir, or you can sometimes you can call it as a length of the weir, this one. So this B by H, H means head over the crest, this one. Head means the water depth above the crest. Here it is depth. If you take here, it will be a depth. So this B by H ratio, if it comes out to be 0.625, less than 0.625, then that particular type of weir is called as a sharp crested weir. Remember, B by H ratio is less than 0.625, then that is called as a sharp crested weir. If B by H ratio is greater than 2.5, take 2.5, it is called as a broad crested weir. If B by H ratio is in between 0.625 and 2.5, it is called as a narrow crested weir. Just look at the picture here. I am showing this one, this picture. So if you look at the crest, it's looking it's a very sharp edged at the top, hence it is called as a sharp edged weir. Here what happens, the liquid or the water will be having a minimum contact with the crest of the weir, and it falls freely, or it springs freely into the downstream side. Okay. Then the narrow crested, as I said, the B by H ratio should be in between 0.625 and 2.5. So this one is called as a narrow crested weir. If the crest is broader and wider, and that type of crest is called as a broad crested weir. Just look the picture here I am showing. So this indicates the broader or the wider, or it is called as a broad crested weir. If you take the ratio B by H, means this is B, this is B, and height, this one is a height. Okay, so B by H ratio, if it is greater than 2.5, so it is classified as a broad crested weir. Okay, so I hope you understood the classification of weirs based on the shape of the crest. So it's very important to identify the weir as a sharp crested weir, broad crested weir, and narrow crested weir. And apart from these, one more type of weir we can classify as a ogee shaped weir. So here look at this picture. Look at this picture here. This shows a ogee shaped weir. So what does it mean? Generally ogee shaped weirs are provided for the spillway of storage dam. You might have seen in case of a dams, the spillway of the dam will be in this shape. That is a storage dam spillway. The crest of the ogee weir is slightly, just look at here, up to here it is a crest. This is a crest, the crust of the weir is slightly rises. See here, this much has risen here. See, it has rised up. The crust of the ogive is slightly rises and falls into a parabolic parabolic shape. See, if you the water is here, the water is coming, and if it falls, then it will be like this, parabolic, like this. Okay, and falls into a parabolic ogive weir is also similar to a flow over a rectangular weir. So the flow over a ogive weir is almost similar to a flow over a rectangular weir, and a reverse curve shaped like an elongated letter S, like this. A reverse curve, elongated reverse curve shaped like a S. See here, this one. Okay, so this is lower nape and this is the upper nape. A reverse curve shaped like an elongated letter S is known as a ogi curve. Okay, and the downstream faces of overflow spillways are often made to this shape. See, the downstream side, it is often made to this shape. That means the reverse letter S. We know in case of a sharp crested weir, see, look at here, sharp crested weir, the nape as it leaves the crust, if it is leaving the nape, just look here, the nape as it is leaving the crust, it springs on rises, means the moment it rises above the crust, it springs, it freely falls on into the downstream side, and slightly at the lower surface, that is it. Just you look here, in a sharp crested where the water is springing down, or it is falling freely. In this way, it releases a maximum rise of, see, if you take a ogi shaped weir, the maximum rise of, see, means the maximum rise here we are getting, just a minute. See, the maximum rise whatever we are getting here means from the crust. If you take the rise, this one, the maximum rise we are getting here as 0.11 H or 0.115 H11, 0.115 H. That is 0.115 H, means 11.5%. It will become, if you convert into a percentage, it will become 11.5% of height of water, means this depth of water. So it will be raised above the crust. Okay, for the smooth flow of water, so it will be made like this, or if you want to get a parabolic shape of the nape, it is being raised above, and this type of weir what we call as a ogi weir, ogi shaped weir. And here what happens in this type of weir, a maximum rise of 0.115 H above the crust and then falls, then it will be looks like a reverse S curve. If the space below the nape, if you take this as a nape, it will be falling like this. What is falling like this? If the space below the nape or below the bottom surface of the nape be filled with a masonry or a concrete, then the consequent weir formed is called as a ogi weir. Means it is not simply a vertical wall, so it is will be completely filled, like filled with a masonry or concrete completely. So you might have seen the spillway upper dam and all, they will be like in this shape. Okay, So if you take other type of weirs, broad crested weir or a narrow crested weir, a sharp crested weir, so here if you take a sharp crested weir, there won't be any material filled here, just it is simply falling freely into the downstream side. But here what happens, whatever the spillway falling down, means whatever the nape is coming down, it will be along the surface of the uh, weir, okay, along the surface of the weir. So this type of weirs are called as a ogee shaped weirs. I hope you understood these classification of weirs. So let us move to the next part. If you look at the application of weirs, where the weirs can be used and all, and what are the functions of these weirs. The data gained from the rate calculation, flow rate calculation, means whatever the data you are getting for the uh, test, means if you are testing the weirs in a laboratories and all, whatever the data you are gaining, means the data gained from the flow rate calculations over a rectangular weir can be used in a number of ways. Means those data can be used for the flood control and general water management policies and practices, and are often designed around such data. And the flow data can be used to determine if a hydroelectric project would be possible or profitable. And also water flow data can be useful for environmental impact studies, specifically in determining how the weir or the other structures would affect the ecosystem of a stream or river. Means by constructing the weir, what would happen in the ecosystem of a stream or a river, that can be studied from the data gathered from the weir. Irrigation and other water uses needs programs also benefit from this kind of data. So these are the some applications of weirs, you can say. Okay, so let us move to the next one. So let us discuss about the broad crested weir. For your syllabus, they are particularly mentioned classification of weirs and derivation of broad crested weir. So in many of the channels or canals, or you can see the rivers, this type of weirs you may come across. So let us derive a equation for the flow rate of broad crested weir. Okay, so I hope you understood the classification of weirs and application of weirs, and the broad crested weir derivation will do in the next part of the video. See, the broad crested weir, as you know, the crested weir support the flow in the longitudinal direction, that is direction of flow. They are used where the sharp crested weirs may have a maintenance problem. The nape of broad crested weir does not spring free, means it will not fall free like a sharp crested weir. So this is called as a broad crested weir. So I hope you understood, and I'll wind up the today's session here, and we'll continue in the next session, that is a broad crested weir and its derivation. Thank you.